So here is the video for Chapter 3 pre-quiz. Okay, so I already posted the answer key, so I'm going to go through every problem quickly here and teach you how to do it. So I might write down something like that, and then I might erase it. So make sure you pause, rewind, do what you need to. Maybe click it at a slower speed because I'll probably talk pretty quick. Okay, so whenever your a is 1 here, you want to factor all these expressions. Almost the whole thing is really factoring. I mean, because that's what this chapter is about. Chapter 3 is about factoring. So whenever our a is 1, we just have 1x squared here. That means we're really going to look at this number c and figure out what times what is 24 but adds to 11. So again, all these you can do cab, even the special cases down here from 7 on through 12 is you can still do cab. Okay, so CA is 1 times 24 is 24. B is 11. Since they're both positive, that means we're going to be adding. And then both the numbers that we find are going to be positive. So what times what is 24 but adds to 11? That is 8 and 3. So this is x plus 8 and x plus 3. And right here we can divide by our a, but that's not going to change anything. So there's our answer. Here, again, whenever our a is 1, really all we do is look at our c and say what times what is 12. And since it's positive, we're going to say what plus what is negative 7. But since that's negative and we're adding, that means they just both need to be negative numbers. So what times what is 12 but adds to 7, and the negatives are taken care of. Okay, so that would be 4 and 3. So negative 4 and just a negative 3 added is negative 7. So s minus 4 and s minus 3. Okay, here's where it gets a little more complicated because now I have an a out in front and my c, so I multiply those two. So 2 times 70 is 140, and my b is 27. So they're both positive though still, so we're going to say what plus what, and they're both going to be positive numbers. So what times what is 140 but adds to 27. So 14 and 10, that's 24. So not 14 and 10. Can't do that. But what about, so we can rework this. Why does my light keep on going on and off? Sorry. Hold on just a second. Okay, so 14 and 10 doesn't work, but if I rewrite 14 and 10 and turn this into a 7 and 2, and 2 times 10 would be 20, so 20 and 7. So 20 and 7 equal 140, and 20 plus 7 equals 27. So here's a little bit more work. So I have the x plus 20 and the x plus 7, but since I multiplied by my a, which was 2, now I have to divide by my a too. So I simplify that, that's x plus 10. And here that doesn't reduce, so I need to take that 2 and move it in front of the x in the parentheses. So 2x plus 7. So that is number 3 there. So I'll probably erase that here in a minute. So if you don't get that down, make sure you get that down. So as we're working through, we're looking at our a and our c. Okay, so we got to take our c times our a, 4 times 15. So I'm going to erase this one. So 4 times 15, that's 60, right? 60, but our b is negative. So, but still, this is positive, so that means we're still going to be adding here. But since this is negative b and negative 16, that just means that both of these numbers are going to be negative. Kind of like number 2 there. Okay, so we're going to multiply. What times what is 60, but still adds to 16? So that's a 6 and a 10, right? 6 times 10 is 60, and 6 plus 10 is negative 16. What you can do, instead of like we did on number 3 here, how I wrote it out as the 2 binomials and then I divided by 2, well, if you want to, you can take these two numbers, negative 6 and negative 10, and just divide them by 2 and reduce the fractions right away. So this is negative 3, and oh, I'm dividing by 4, sorry, not by 2. So I can reduce those fractions. So I'm dividing by 4, my a, and this becomes negative 3 halves, and this becomes negative 5 halves. Now, since I can't reduce anymore, I can take these denominators, and that's what goes in front of my variable z. So 2z minus 3, my numerator. So my denominator goes in front of the z, my numerator stays in, and then this 2 is going to be moved in front. So 2z minus 5. And there you go. Okay, so that's how you can do that without writing. So you might have to write a little less, maybe. Okay, so now we have 8 and negative 21. So that's a negative 168 is your C, and then your B is negative 22. Okay, so since you have a negative here, that means you're going to be subtracting to get to your two numbers. And since this is negative, that just means whatever the bigger number is going to be negative. So we're still going to be subtracting, so we're asking ourselves, what times what is 168, but then subtracts to 22? So we know we multiplied 8 and 21, so I can rewrite 8 as 4 and 2, and 21 is 7 and 3. So if I multiply 4 and 7, that'd be 28, and 2 and 3, that'd be 6, and I see since I'm subtracting, 28 minus 6 is indeed 22. So 28 and 6 is our numbers, and then just our b, since our b is negative, our bigger number is going to be negative. So this is negative, and this is going to be plus 6. And so if you want to, you can go ahead and divide those two numbers by our a, which is 8, 8 and 8, and reduce these fractions, this one by 4, so 7 over 2, this one by 2, which is a positive 3 over 4. Now we can move these denominators in front of our variables. So 2y and then minus 7. And this one is a 4y plus 3. And you can always FOIL this out. If you FOILed this out or use the box method, you'd get back to your original starting point. But at least you could check this. 2y plus times 4y is an 8y squared. Right? So at least you could check that, if not anything else. Okay, so let's go ahead and move to 6, and I'm going to clear some of this out. So if you don't have these answers down, make sure you have these answers down, because I'm going to clear everything. It's kind of getting cluttered. Okay, so now it's kind of cleared. Let's go to 6, and we always want to check to see if we can factor out the GCF, right? We always want to check to see if we can factor out the GCF, and that's probably what I should have did from the beginning, but none of those I could have. But let's check this. 9, 48, and 64, so they're all numbers, so I can't take out a variable because there's not a variable in 64. And the numbers, I can think about 3, but 3 doesn't go into 64, so I can't factor out a GCF. But what I do notice on this trinomial is that this is a 9 and this is a 64. That's called a perfect square trinomial. Well, we're going to see if it's a perfect square trinomial. But those two numbers, 64 and 9, are perfect squares, and so is x squared. So 3 times 3 is 9, and x times x is x squared. And 8 times 8 is 64. And then if I multiply those together, so 3 times 8 is 24, times x is x, 24x. And then if I times that by 2, so times that by 2, do I get my middle, 48x? And I do. That means this is a perfect square trinomial. So 3 times 3 is 9, x times x is x squared, and 8 times 8 is 64. And my middle is a positive, so that means this is going to be positive. And then all I have to do is just square this. Or I could write it like this, 3x plus 8 and 3x plus 8. Or I can do 3x plus 8 quantity, parentheses, squared. Right, because it's a perfect square trinomial. All right, now let's look at this one. This is another special case. There's only two terms here. This is my A, right? 1 is my A, and negative 64 is my C. So I could still do CAB. So negative 64, but my b, I don't have a linear term. I don't have a plain variable in the middle, right, without the squared. So that my b is 0. So I can do what times what, what times what is 64, but then adds to 0. Well, since this is negative, we're actually going to subtract to 0. That means they have to be opposites, right? So 8 times 8 is 64, and 8 minus 8 is 0. So we have g minus 8. And g plus 8. So these are called perfect or difference of two squares. Same with 8. 4 is something squared. It's 2 squared. 2 times 2. S squared is s times s. 25 is 5 times 5. And then to get a negative, I need one positive and one negative. So that is 2s plus 5, that's what it looks like, and 2s minus 5. They don't look like, they both kind of look like s's, but one's an s and one's a 5. Same thing on 9. What times what is 49? That's 7 and 7. What times what is t squared? That's t and t. What times what is 9? That's a 3 and a 3, and then one's going to be positive, one's going to be negative. It's called the difference of two squares. Here we have 4 terms, and again, even I kind of messed up, not really, but I always should look at my terms, no matter if I have 2 or 3 or 4, or however many, and say, can I factor anything out, right? So I always want to check that, so I haven't been doing that, I'm sorry. So 6, 15, 8, and 20. I almost could take out a 2, but that 15 I can't take out a 2, right? And I can't take out a 3 out of 8 or 20, so it's probably, that's all I can do, right? I can't take anything out. But look for the variable now. R, 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 no R, so I can't take any variables out. So now I want to do the factor by grouping. I put a line through this. I look at this side. And see, can I take, what's the greatest common factor that I can factor out here? So that is a 3r squared. Okay, and then I get left with 3 times what is 6, that's a 2. R squared times what is r cubed, that means I need another r. 3 times what is 15, that's a positive 5. And I have an r squared, so I don't need any more r's. This side, I should get left with a 2r plus 5. And you can check. So we ask ourselves, what times 2 is 8? That'd be 4, right? A positive 4, so put plus 4. And then you can check. Ready? 4 times 2r is a 8r. 4 times 5 is a 20. So there you go. Now you factor out what's the same on this side and on this side. That is a 2r plus 3. So you factor that whole binomial out. What's left? A 3r squared and a plus 4. So there you go. And then just in case you forgot to factor out the GCF, you can look at this. Can I factor any more out? Can I factor any more out? Okay. Same thing with this. Can we factor anything out? Maybe a 3. Nope, 3 doesn't go in a 10, so probably not. So we look at this side. We can factor out a what? 2. And what about the c's? I can factor out, we'll look at the smallest denominator, or exponent, which is a 2. So 2c squared. And what's left? 5c minus 6. So that means this side should be a 5c minus 6. And what times 5 is 15? That's a positive 3. And check, 3 times 5c is a 15c, and 3 times negative 6 is a negative 18. Now factor out what side from this side. That is a 5c minus 6 is in both of them. And then what's left? A 2c squared plus 3. And then again, check. Nothing's the same, so we are done. So that's our answer to 11. 18, check. There is a 2 in all those, right? So we can factor out a 2 first. We get an 8, right? Ooh, that's an ugly 8. 8w. Ooh, that's an 8. 8w. 8w cubed. Because I can't take a w, right? Because there's no w here, so I can't take a w out. So 8w cubed plus 4w squared plus 14w plus 7. Okay, now we're going to divide this in half. What can we take out of here? That would be a 4, right? What about w's? The smallest exponent is 2, so w squared. I get left with a 2w plus 1, right? Because 4w squared times what is 4w squared is 1, so I have to have that plus 1 there. This parenthesis should be the same, 2w plus 1. So what times 2 is 14? That would be a positive 7. Now check the rest. 7 times 2w is 14w, and 7 times 1 is 7. Now what's the same in both? That would be 2w plus 1. And what's left when I take that out is a 4w squared plus 7. So there's number 12. Oh, don't forget this 2 that we factored out from the beginning. It needs to be up front as well. Okay, so I'm going to erase that. So if you don't have that down, make sure you pause that now. Write those down, and I'm going to start doing with 13 through 16. Okay, so 13, again, this is all about factoring, so we're probably going to still factor because we're looking for area of a rectangular field. So that means we have a rectangle, right? Of this trinomial is the given area, and we want to find the length of the rectangle it's given to us, t plus 5. We want to find the width, right? So basically, we're factoring it. We already know one factor is t plus 5. We want to find the other factor. So again, you could just do cab if you wanted to, and you'll find out that the one side is t plus 5, and then you could find the other side. So you could do cab here and be done, right? I'm just going to say, hey, I know it's always first times first gets me that first term, right? T squared. So I can ask myself, t times what is t squared? Well, that would be a t. Then I know last times last gets me the last one, which is negative 45. And I already know one's a t plus 5. So now I have to ask myself, 5 times what is negative 45? That'd be negative 9. Now I need to just check the middle. So 5 times t is 5t. And t times negative 9 is negative 9, so negative 9t plus 5t is indeed a negative 4t. So my answer is this side, because I already have this side, right, my length, so here's my width, t minus 9. Okay, same kind of thing on the next one. We're still going to be factor. We're looking for the area, right, or we're given the area right here. And we want to find the length of the rectangle. Oh, they give us the length. Now we're asked to find the width. So here, again, same thing. You could do cab if you want to. You'll find out that one of the factors is 5x plus 2, and you got to find the other one. Okay? But I can, again, it's always first times first. So first, and oh, here, let's do the rectangle, right? I know first times first. So 5x times something up here is going to give me a 10x squared. Ooh, that's a beautiful 10. A 10x squared. So I can ask myself, 5 times what is 10? That's 2. X times what is x cubed? Or sorry, that's supposed to be squared. Sorry. Squared is an x. So I know the first one should be a 3x. And then the last one, if I have 5x here, that means I have a plus 2 down here. So 2 times what is the last term, which is a negative 14. So 2 times what is negative 14? That would be a negative 7. And then we can check the middle, right? So this should be our answer. We're going to go ahead and check it. So 2, that's a positive 2. 2 times 3x is a 6x. And then 5x times negative 7 is a negative 35x. I add those together, which is really subtracting, right? And it's a negative, oh, this is a 2 up here. Sorry, that's not a 3, that's a 2. Right, because 2 times 5 is 10, so that should be 2. So that's not 6, that's 4x. Now if I add these together, don't I get a negative 31x? And that's true, so that is my width right there. Okay, now I have the area of a square room, so that means both sides are square. So this side is the same as this side. And what's the length of the one side of the room? So we only want one of these, right? We don't need them both, we just want one. So again, you could use cab and you can factor, but since these sides are the same, that means we're probably going to have the same exact set of parentheses, or parentheses squared, which means that we have a perfect square trinomial, right? 16 and 81 are perfect squares. What times what is 16? That's a 4 and a 4. X times x is x squared, so x and x. And then what is 81? It's a positive 9 and a positive 9. And then 4x times 9 is 36, and 4x times 9 is another 36, and that equals 72. So that means that our side that we're looking for, one of the sides, this could be rewritten as 4x squared plus 9 quantity squared, but we're looking for just one of the sides. So one of the sides is just 4x plus 9, because it's square, right? Both sides are the same, but they were asking for just one side. Now I have a rectangle prism. So what that means is has volume. That means it has 3 dimensions, right? So we need 3 terms. So usually it's probably going to be your GCF, parenthesis, right? So that means we're going to factor the GCF out. So what can we take out? Look, they all have x's, so we'll take out an x. And they also have a 2 that I can take out. So what gets left is a 2x squared plus 15x plus 18. Now I can go ahead and do cab. So c times a is 36, because 2 times 18 is 36. My b is positive, so these are both positive, so that means we're going to be adding, and both the numbers that we found are positive. So what times what is 36 but adds to 15? So that is 12 and 3. And then we go ahead and divide by our a, which is 2. 12 divided by 2 is 6, so we have x plus 6. 3 divided by 2 I can't do, so I'm going to move this 2 out in front, so 2x plus 3. And then I bring down that 2x that I factored out from the beginning. So those are all the 3 sides. So those are possible dimensions, the linear dimensions. These 3 are all linear factors there. Alright, I'm going to give you a second real quick, copy down those answers if you haven't got them down, because I'm going to erase it here in a second. So pause it if you need to, because it's going to be gone. I guess that's silly me saying that, because you could easily rewind it and have them. So, it's gone. Okay, so 17. We're telling how we understand, so we're describing what's happening. So if you want to, you can do the problems, right? But you're just telling what are you doing in your head, what are you asking yourself, right? So here I'm asking myself, what times what is 81? So you'd write that down. So I'm describing how would I factor it. I'd ask myself, what times what is 81m squared, right? And that's a 9m. Then I ask myself, what times what is 25? Or really, it's what times itself. And that's 5, right? And then I say 1 positive, 1 negative. So a negative, another 1 positive. Okay, here's a perfect square trinomial, right? We got 4 and 16. So we just go ahead and ask ourselves again, what times what is 4? What times what is 4 and x squared? So that's a 2x and a 2x. And then what times itself is 16? Again, that's 4. Oh, it's 4, not again, it's 4, but it's just 4. So that's a positive 4 and positive 4. But since our middle is negative, that means both of them need to be negative. And so that's what we write. So we would ask that, and we say both negative. Here, ask yourselves what times what is 9, and what times what is 49. And then since b is positive, we both positive. So it'd be 3x plus 7, 3x plus 7. All right. I'm going to clear that, so you might have to rewind that or pause it and write those answers down. Okay, now we have to reason, we have to think with ourselves. Okay, so we have a trinomial. A is in front of x squared, and c is our constant, right? And we take a times c, and if our ca is negative, what does that mean we're going to do to get to our b? What are we going to do to get to our b? Think about it. Pause the video, because I'm going to answer. Since it's negative, we are going to subtract. So what do you do to know about the factors? So what do you know about the factors? So if that's, we're going to subtract, right? And if b is positive, what does that tell us about these two numbers that we find? Okay, pause the video if you need to think about it. Okay, I'm going to answer. Since this is negative, we're going to subtract. And since b is positive, that means the larger number, so the big number, is positive. Small number is negative. Okay. Describe how you find the linear expression of this, right? Just like the one back up here. I don't know if it was like number 15, 12, number 12, I think, number 12. First things first, what do we do? What do we always do? And that's what you say. Okay, so what do we always do first? Okay, pause the video. Okay, I'm going to answer. We factor GCF, right? Then once we factor that GCF, right? So that'd be 2k, 4k squared plus 13k plus 3. Then we cab or factor the trinomial. Then cab factor the trinomial. Right? That's how we would do it, and then we would factor that. Open-ended question, come up with two two different types of trinomials, right? So here, when we factor this one, we get left with two binomials, right? So if I want to come up with two trinomials and then factor them, can I just come up with two binomials? Sorry, I might have said that backwards. If I want to come up with two trinomials and then factor them, well, here I had a trinomial, and to get my answers, didn't I factor them into two binomials? Well, can I make up two binomials and multiply and come up with a trinomial? Sure. So x plus 2, x plus 3, multiply them, right? And that would create a trinomial. There we go. So there's my trinomial, and I already factored it. And I could do that again. So you can go ahead and come up with your own. I'll just make one up, right? 2x minus 3 and a 5x plus 7. Right? And then I could just multiply this out. I know I'm going to get a 10x squared. I know I'm going to get a negative 21. And then I can multiply my middles. Right? 14 is, so plus x. Right? There we go. So there's my answer. Now one that is not factorable. I can't factor it. And why can I not factor it? So we multiply, right, our c times our a, it's either positive or negative, right? And then your b is either positive or negative. So when it's positive, right, when it's positive, then I add to get to my b. When it's negative, I subtract to get to my b. Well, if it's not factorable, what do I do? Or I guess ask yourself, what do I ask myself to get to my CA? So if I have a number here, 12, what do I ask myself? What and what? And then in order to get to my b, what do I ask myself? Okay, so say if my b was 7, what would I ask myself? So if that was my CA and that was my b, what would I ask myself? What would be the question here, and what would it be here? All right, go ahead and pause the video, think about it, come back. All right, so I always ask myself, what times what is 12? And then since they're both positive, then I would say they need to add up to that number, right? Well, here if I don't want one's factorable, then I need to come up with two factors of 12, or any factors of 12, or actually all factors of 12, 3 and 4, 6 and 2, and what do you got? 1 and 12, sorry. And then say, make sure that they don't add up, because I don't want them to add up, because if they do, then it means it's factorable. But if they don't add up to this b, then we're great, right? So let's find out what does add up. So these add up to 7, this adds up to 8, and this adds up to 13. So we don't want these to add up there, right? We don't want our b to be any one of those, and then we could use our CA as 12, right? Because if it doesn't add up, that means I can't factor it. So we want our CA to be 12, so any combination, so it could be 3x and a 4 out here. Right, and then our b could be 7. It could be, or it can't be 7, because if it is, then our factors would be 3 and 4. It can't be 8, because then it would be 6 and 2. It can't be 13, because it would be that. So any numbers besides these. So it could be 10. So I could do plus 10x, then plus 4. So that, and then squared, right? Forgot to put the squared there. So that would be a trinomial that's not factorable. Okay, so you try to come up with a different one by yourself.